Hello friends, welcome back to the channel. In previous video, I explained the OSI model in light of the gift sending scenario. I hope you might have understood. Now I am going to provide a comprehensive detail on the function of every OSI model layer. In today's video, we are diving into something fundamental, the OSI model, which is the backbone of how computers talk to each other. In this part, I am discussing only first 3 layers of OSI model, while the remaining will be uploaded in the next video. So don't forget to subscribe to the channel by hitting the bell icon so you may get notification of future videos. Before we go into the layer, let's first understand what is the need of data communication standard. Imagine you are trying to send a message in a language like English to someone who only understands Chinese or some other language. Well, it is hard for the Chinese to understand and it won't work unless there is a common understanding in between. That is exactly why we need standardized communication protocol to allow devices from a different manufacturer using different software and hardware to exchange data seamlessly. These standards are also known as protocol or rule, which are responsible for providing connectivity and data communication for the different stakeholders in networking and data communication. These standards help in identifying the devices on the network, understanding the data transmission procedure, data processing, and its delivery to the destination. Some of the well-known examples are TCP/IP, IPX, DECnet, AppleTalk, and NetBIOS. After understanding the standards of data communication, now we are moving on to understand what is OSI model. OSI stands for Open System Interconnection. In the late 1970s, as the network started becoming more complex, the International Organization for Standardization, which is also known as ISO, proposed a universal model to standardize how devices communicate. It was officially introduced in 1984 as the OSI model, providing a 7-layer conceptual framework for data communication. The OSI model helps network engineers and students to visualize what happens when data is transmitted from one system to another. OSI model also helps in understanding how data is received, how nodes communicate in different languages, how devices are connected with each other through physical media, and how data is arranged, and so on. There are 7 layers in the OSI model. If you want to remember these layers, then there is a proper node sentence which helps you to memorize the names of the layer in sequence. This one is, please do not throw sausage pizza away. Or there is also another sentence which is very common. All people seem to need data processing. Let me clear one thing. If you are new to this, some people call physical layer first layer, while others call the application layer first. There is nothing wrong with it. If you are starting from sending data from sender to receiver, then you are okay with calling it application layer as the first layer. But if you are talking about the physical transmission of data, then you may call physical layer as the first. Now, we will start from sending data on a physical cable or media. So in this discussion, our first layer will be physical layer, and then we will be proceeding on. As you know, the OSI model layers are divided into 7 layers. The application, session, and presentation layers are called user support layers, while physical, data link, and network layers are called network support layers. And transport layer creates a bridge between the user support layers and network support layer. The OSI model is divided into 7 layers, but in this video we are focusing only on the first 3 layers, which are dealing with the actual moment and delivery of data. Let's discuss them. Let's start from the physical layer of OSI model. Think of this as the road where your data car will drive. This is the lowest layer. It deals with the actual physical connection. Physical means sending of data over physical wire such as coaxial cable, twisted pair cable, or optical fiber. Similarly, the data can also be transmitted with the help of wireless transmission. The major function of physical layer is to transmit stream of bits over medium. There are several functions of physical layer. Let's discuss them, each one of them. The physical layer deals with the characteristics of medium like their material, structure, shapes, or ways of sending data. This layer also deals with the interface between the medium and devices. It means that how cable will be connected to the connector and how they will be plugged into the connecting devices. The physical layer of OSI model is also responsible for doing encoding and decoding. Encoding is normally done at the sender side while the decoding is done at the receiving side. Encoding is the process of converting digital bits into signal, which are then sent over the medium. While decoding is the process of converting signal back into the digital form, which is understandable by the receiver. The physical layer of OSI model is also responsible for the data transmission of digital and analog signal, like it performs broadband communication, which is the process of sending digital data in analog form. While there is also baseband communication, which is the process of sending data without conversion, such as sending digital data. The next layer of OSI model is data link layer. The data link layer is the second layer of OSI model. It is responsible for ensuring a reliable link between two directly connected devices. It takes data from the network layer, breaks it into frames, adds physical address, and handles error checking before passing it to the physical layer. It ensures that the message arrives intact at the next hop. The major function of data link layer is framing. Framing is the process of taking raw data from physical layer and wrapping it with headers and trailers to create structure units which are called frames. This process is called framing, which is done at the data link layer of OSI model. These frames include addresses and error checking code, which helps to ensure that the data is correctly sent and received. It is just like putting documents into labeled envelope before mailing them. The second function of data link layer is physical addressing. At this layer, data is sent using physical addresses, which are also known as MAC addresses. The size of the MAC address is 48-bit. Every device has a unique MAC address assigned to its network card. This allows the data link layer to direct each frame specifically to the correct machine on the local network. The concept of physical addressing can be well understood in this diagram. Suppose PC1 is sending a frame to PC3 that contains the source and destination MAC addresses. As the frame is received by the switch, then it looks into its MAC table for matching the destination MAC addresses in the frame and forward the frame to the intended device. The third function of data link layer is network topology. Network topology we have discussed in the previous video. It is the arrangement of devices in a network, like how devices are connected in a different shape, such as ring, star, bus, or mesh topology. Based on handling access and flow of data, the data link layer decides which topology is to be adopted. Physical link management is another function performed by data link layer. Physical link management is about setting up, maintaining, and ending the connection between two devices over a physical medium. The data link layer makes sure both devices are ready for the communication, handles signaling, and ensures smooth flow, almost like managing a conversation line between two people. The data link layer finally performs bit ordering. Bit ordering is the process of determining the sequence in which bits are sent over the network, whether the most significant bit LSB or the least significant bit LSB goes first. The data link layer ensures both the sender and receiver agree on this order so data is correctly understood. Similarly, we have discussed the synchronous and asynchronous communication. The data link layer decides that which communication should be adopted. Welcome to the third layer of OSI model, which is called network layer. This is the layer where things get smart. Why? Because it is responsible for delivering data across different networks, not just within the same local area network. There are several functions which are performed by network layer. The first one is called the conversion of logical address into physical address. Let's start with how devices identify each other. Every device on a network has a logical address, like an IP, a kind of like a postal address for the computer. But machines don't speak in IPs at the hardware level. They need MAC addresses or physical addresses. So the network layer uses something called address resolution protocol to translate the IP address into the physical addresses. It is just like looking for someone's house number when you only know their name. The mechanism of finding physical address from the logical address can be well illustrated in this diagram. In this diagram, the device A wants to find the physical address from the IP address of device C. This process completes in 4 steps. In first step, it checks its URP cache for the MAC address of having IP 192.168.1.20. If it is not found, then in next step, it sends URP request to all devices, and the device with IP address of 192.168.1.20 forwards its MAC address to device A. Now device A knows about the MAC address and starts sending data to device C. Another function performed by the network layer is path determination. Now that we know where to send data, we need to figure out how to get there. That is where path determination comes into play. This layer checks the current traffic, the number of hops, and link conditions to decide the most efficient route to the destination. It is just like choosing the fastest road on the Google map. Remember one thing, shortest doesn't always mean fastest. Now we are going to discuss another major function of network layer, which is known as routing. Once the path is decided, it is time for routing. The process of actually forwarding data across the network is called routing. Routers, which operate at this layer, read the destination IP address and decide which direction to send the packet. They rely on the routing table and protocols like OSPF, RIP, and BGP to make smart decisions. Think of router as a digital traffic controller guiding data through the internet highway. And the fourth function of OSI model is IP addressing. Let's talk about IP addresses. These are the logical numbers assigned to every device connected to the network. There are two main versions. One is called IP version 4, while other one is called IP version 6. These addresses ensure that the data reaches the right devices, no matter how far away it is, even across the countries or continents. Flow control is another function which is performed by network layer. While the transport layer mainly handles flow control, the network layer still plays a part. If routers detect that data is arriving faster than it can be forwarded, then they slow down the flow by buffering or dropping packets. This helps to prevent the network devices from getting overwhelmed. Think of it like a traffic signal slowing down vehicles to prevent a jam. And finally, we come to the congestion control. If too much data flood, the network routers get overloaded and packets start getting dropped. This causes delay or even communication failure. To fix this, the network layer uses techniques like packet queuing, priority management, and feedback signal to balance the load. It is like reducing the traffic on a busy road to keep things moving smoothly. And that's it. We have discussed the physical data link and network layer along with their functionalities. The next layer of OSI model will be discussed in the next video. So stay tuned and don't forget to like the channel, subscribe to the channel and hit the bell icon so you don't miss any future video. Thanks for watching.